son Ernie is turning in circles. From our perspective, Ernie is moving and the room he's in is standing still. But from Ernie's perspective, he is standing still and the room around him is moving. This type of illusion is called apparent motion. Apparent motion is a motion of an object that is not real, but an illusion caused by the movement of the observer. As we've already discussed, the Earth is constantly moving. We are rotating around our own axis at the same time that we are revolving around the sun. This constant movement creates the illusion of what we call apparent motion of celestial objects. And these objects include the sun, the moon, the stars, the planets, and anything else that is outside of Earth's atmosphere. Today we're going to consider just the most important celestial object in our sky, the sun. In order to understand the apparent motion of celestial objects like the sun, it helps to envision the sky as a dome with a person standing right in the middle. Now, the basic apparent motion of the sun is that it rises in the eastern side, it climbs up, 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 up in the sky until it gets to its highest point, which we call noon, or sometimes solar noon, and then it starts to descend down the other side of the arc until it sets on the western side. Let's review. Number 1. Because Earth rotates, the sun appears to move across the sky from east to west. Number 2. Solar noon is when the sun is at the highest point in its arc. Now this basic model becomes more complicated for two important reasons. The first is that your latitude determines where the sun appears at solar noon. If you live in the northern hemisphere, solar noon is going to be in the southern sky. If you live in the southern hemisphere, the sun still goes from east to west, but solar noon is going to appear in the northern sky. The reason for this is that the sun's direct rays always shine on the low latitudes, which is basically near the equator. So if you're in the northern hemisphere, you have to look south to see the sun, and if you're in the southern hemisphere, you have to look north to see the sun. The formula for figuring out the altitude of the sun at solar noon is equal to 90 degrees, which would be directly overhead, minus your latitude. So in Rochester, New York, the latitude is about 43 degrees. So 90 minus 43 means that the altitude of the sun at solar noon would be 47 degrees above the horizon. The second reason that the model becomes more complicated is because the Earth is tilted 23.5 degrees on its axis. The reason for the seasons is because of the Earth's tilt. The seasons are caused by Earth's tilt. The seasons are caused by Earth's tilt. That is one of the number one misconceptions in Earth science. People think that it's caused by some other reason, but it's caused by Earth's tilt. In this diagram, you can notice that Earth's tilt is always pointed in the same direction. We call that parallelism of the axes. And you'll notice that at one time of year, the North Pole is pointed towards the sun, and that would be summer in the northern hemisphere, and it would be winter in the southern hemisphere. On June 21st, when the North Pole is tilted toward the sun's light is directed at the latitude 23.5 degrees north of the equator, which is known as the Tropic of Cancer. This causes an important change in the sun's apparent path through the sky. Basically everything, sunrise, solar noon, and sunset, is shifted 23.5 degrees to the north. The sun's path looks like this. The sun rises 23.5 degrees to the north of east. At solar noon, the sun will be 23.5 degrees higher in the sky, and the sun will set 23.5 degrees north of west. Also, notice how long the sun is in the sky. This is why days are longer in the summertime. You'll notice on the other side here that the North Pole is pointed away from the sun, and so that would be winter in the northern hemisphere and summer in the southern hemisphere. On December 21st, when the North Pole is tilted away from the sun's light is directed at the latitude 23.5 degrees south of the equator, which is known as the Tropic of Capricorn. This causes the apparent path of the sun to shift everything, sunrise, solar noon, and sunset, 23.5 degrees to the south. The sun's path looks like this. The sun rises 23.5 degrees south of east. At solar noon, the sun will be 23.5 degrees lower in the sky, and the sun will set 23.5 degrees south of west. Notice how briefly the sun is in the sky. This is why the days are shorter in winter. The other two dates are the equinoxes. The one on the top is March 21st, that's the spring equinox, and the one on the bottom is September 23rd, which is the autumn equinox. And in both of the equinoxes, the sun's direct rays are focused on the equator. On the equinox, every part of the planet experiences 12 hours of daylight and 12 hours of darkness. The sun rises directly in the east. Solar noon for Rochester has the sun about 47 degrees above the horizon in the southern sky, and the sun sets directly in the west. Let's review. On the equinoxes, March 21st and September 23rd, the sun rises directly in the east and sets directly in the west. The altitude of the sun at solar noon equals 90 degrees minus your latitude. On the summer solstice, June 21st, sunrise, sunset, and solar noon are shifted 23.5 degrees to the north compared to the equinox. And on the winter solstice, December 21st, sunrise, sunset, and solar noon are shifted 23.5 degrees to the south compared to the equinox. And lastly, the seasons are caused by Earth's tilt.